Fields Around Me project, at its core, is the effort towards the design and implementation of a DC-accurate wireless biopotential sensor. The driving force behind this project is the development of an ecosystem of devices and applications that can be used to sample and analyze the biopotential behavior of living organisms. The collected data is sent to and then stored on a server as well as a cloud storage service. This data can then be viewed from both a mobile application for Android devices or a desktop application developed for any machine that is capable of running a modern Windows operating system. The goal of this data collection effort is that in the future, this data will hopefully be used to correlate with external databases such as those of solar activity to quantify the effects of extremely low frequency signals such as Schumann resonance and the effects that these signals have on the human body. Without the existence of a reliable way to measure this data, it is currently impossible to measure the amounts of extremely low frequency and electromagnetic phenomena that the human body is exposed to on a daily basis. This is not even taking into account the effects that these signals might have on the human body. This is worrying, as in recent studies it has been found that periods of increased solar activity that lead to increases in extremely low frequency signals as well as electromagnetic phenomena have been seen and observed to increase the heart rate within an area by up to 5 to 10%. By implementing modern hardware advancements, it is hoped that it will be possible to accurately measure these effects and perform data correlation in the future to observe the effects that the exposure to electromagnetic phenomena and extremely low frequency signals and the effects they may have on the human body.
First, the silver nitride electrodes read the raw biopotential data from the tree. Then the analog signal goes through our signal processing on our custom PCB and into our 24-bit ADC to get a digital signal. The ESP32 microcontroller mounted on the PCB then logs the data to a micro SD card on the SparkFun serial data logger daughter board, and it also simultaneously sends that data to the server. The server then logs that data and acts to communicate directly with the desktop app in order to graph the data and retrieve data from external databases.
Next, we're going to show the actual compilation and calibration process for the wDABS sensors. In the Arduino IDE, upon first upload, we see that the sensor connects to MQTT and Wi-Fi via the serial monitor, as well as informing us that we have all of our necessary ADC setup completed. Now, we calibrate the sensor by taking the difference in the voltage from our battery pack divider connected to the input terminals with the batteries out and then with the batteries put in, so we can get a baseline for our calibration. Once the baseline is established, we restart the code and our settings are saved in our preferences for future use. Now that the sensor is ready, let's move server-side.
This is the desktop interface. Here we're going to open the settings menu, and we can set the IP address of our server along with the sampling frequency of the wDABS sensor. We can also set sensor number and name. We then save these settings to a JSON file, and then whenever we click source, we can select Wi-Fi to get live data from the Raspberry Pi server, which is read in from the wDABS sensor. And it's just DC values right now, so it's just straight lines on the graph. Then we will graph an API. We'll be choosing the humidity data from the SWIRLL. It will pull up a date picker window where you select the start date and end date that you want to graph. It will then spawn an API pop-up, which then graphs the data from the server